Welcome dear students. This video tutorial is done as a part of the course EE307 Signals and Systems. So in this tutorial we will be basically doing an introduction to Matlab programming because in the coming days I will be giving some assignments that need to be completed in Matlab. And moreover, if you do exercises in Matlab, it will give you more deeper understanding of the subject. So that's why we will be doing some of the exercise in Matlab. And in this video tutorial, we will try to give you a base on how to work on Matlab, what are the different interfaces that are available in Matlab, and more importantly, recently Matlab is available online. So I want to show you how to access the online Matlab which is available. And our campus is already subscribed to Matlab, and hence we can use the opportunity that is available. So let me go to the tutorial. So let me show my screen. So you can access Matlab in different ways. So one way is that if you have installed the Matlab in your computer. So here in my computer I have installed the Matlab software itself. So you can click on that, and it will open up an interface like this, and you can do the programming using this. So I'll explain the different components. Uh, the other method is what I want to more focus on, which is the Matlab online. So I'll just close this window for the moment, and let me open Google Chrome. So the good thing is that we can access Matlab through online. That is, even if you do not have Matlab installed in your computer, you can access Matlab through your browser. For that, what you need is you need to have a MathWorks account, and that too using the TKMCE mail ID. So I have informed that you must create a MathWorks account using the TKMCE mail ID. So once you have created the MathWorks account, what you need to do is you need to type in matlab.mathworks.com. Okay, so please take note of this URL. The URL for getting Matlab online is matlab.mathworks.com. So if I press enter, it will go into the latest Matlab. So you can see that it is Matlab online 2020A. So once you enter this, it will ask for that particular mail ID. So my TKMC mail ID is matthew@tkmc.ac.in, and then it will ask for the password. So you need. So once you enter the password, you will come into such a frame, or such a facing panel. So here I'll tell the main tabs that you need to be careful about. So one important tab is this command window. Okay. So here in this command window, we are basically giving the commands, and we are observing the output in this command window. And another important space or tab is this workspace. Okay. So this workspace is the place where the variables are being stored. So as the name suggests, MATLAB is basically it's matrix laboratory. So whatever you do in MATLAB, the operations are considered as doing in matrices. So even if you are defining a scalar, it will be considered as a one by one matrix. Or if you are defining a vector, it will be considered as a matrix. For example, if you define a vector of 1 2 3, it will be considered as a matrix of dimension uh, 1 by 3, and you can define the matrix as well. So first I will show you how to define a scalar, a vector, and a matrix, and I will show you how it will come in the workspace. For example, so suppose I want to define a scalar a, and let me define the value of a as 2. Okay, so I have entered a is equal to 2 in the command window, and when I press enter, you can see that that particular output is displayed in the command window, and at the same time the particular variable is stored in the workspace. So now a is stored in the workspace, and the value of a is also shown, and the size is, as I have said, it is a 1 by 1 matrix. Now suppose you type in again a in the command window and press enter, you can see that whatever was there in the workspace, it is shown in the command window. Okay, so this is the relation between a command window and a workspace. Whatever variable you are using, that will be saved in the workspace. Now let's see how to define a vector. Suppose I am defining a vector b as 1 2 and 3. So vectors, the elements in the vectors need to be defined with space in between. So this is a it's a three-dimensional vector, and if I press enter, you can see that that particular vector output is appeared in the command window, and at the same time the variable is stored in the workspace as b with the value 1 2 3, and it's a 1 by 3 matrix, 1 by 3 matrix. So similarly you can define a matrix like this. So for example, 1 1 2 3. uh, Suppose I am defining a 3 by 3 matrix with elements 1 2 3 in the first row, second row become 4 5 6, and third row 7 8 9. Okay, so for that you need to use semicolon to separate out the different rows. So 1 2 3 is first row, 4 5 6 is the second row, 7 8 9 is the third row. Okay, and if I press enter, you can see that C is defined as a matrix of 3 by 3 dimension, and the elements are 1 2 3 4 5 6 7 8 9, and that particular variable is defined in the workspace as well. Okay, so you can recall any of these elements in the workspace directly to the command window. Okay, so now I want to tell you about two important commands which are normally used in the Matlab coding as first two lines. So the first command is a command called clear. Once you type in clear, you can see the explanation. It remove items from workspace. So now currently workspace is filled with three variables a, b, and c, and if you write the clear command, I am now pressing enter, you notice the change in the workspace. So if I press, if I use the clear command, you can see that the workspace is being cleared now. Similarly, you can use one more command, which is CLC. It is to clear the command window. Suppose you want to clear this command window, you can use the command CLC. Okay, so I am pressing enter. Now you can see that the command window is being cleared. So these two lines are generally used at the starting of any coding. Now let me go to the coding. So as I said, command window can be used to enter the commands as well as to see the output. But in general, you will write the program in something called as script. Okay, or otherwise it is called as M file. So, and you will observe the output only in command window. You generally don't write the program in command window, but you can write in command window as well. But in general, you will write the program as an M file, and you will run the program, and you will observe the output in the command window. So let me show you how to take the M file or new script. For that, you can either click on this new script, or you can go to new and select script. So let me select script from here. So a new M file is being created, and first thing you need to save this. So let me save this as basics underscore Matlab, and now it is saved as an M file with .m extension basics underscore Matlab. If you are doing it in Matlab online, you can see that that particular file is stored and is shown here. Okay, so this section is basically showing the current folder. That means since it is Matlab online, you are having a Matlab drive, like something like Google Drive, and in that you can store the files here. If you are using the Matlab in your computer, you can select which folder, which is the current working directory. Current directory can be set here, and this M file will be saved in that particular folder. Okay, now so this basics underscore matlab.m is saved here, so you can call this at any time. Suppose you have closed this, you can double click and open it again. Okay, so what is the first two lines that you want to use? The first line is clear, the second line is CLC. Okay, so do this practice so that you can write neat programs. So clear will clear the workspace, CLC will clear the command window. Okay, so let's try to do whatever we have done in the command window. So let's once again define a scalar a is equal to 2, and the way to execute this M file is that you need to use this particular button called run button. So if you press this run button, you can see that the output is appeared in the command window, right? So you have defined a as 2, which you have done in the command window earlier, but right now you are using the M file to do the operation. So a is equal to 2 is appeared in the command window, and at the same time the variable is appeared in the workspace as well. Okay, so similarly let me write b as something as 2 3 4 5. Okay, so b is a vector. Now if I run it once again, so here the execution will be line after line. So the Matlab will first run clear command, so it will clear the workspace. Then it will run CLC command, so it will clear the command window. Then it will go to step 3, there is nothing, so step 4, a is equal to 2, and so on. Okay, so you can see that a is equal to 2 is there, b is equal to 2 3 4 5 is there, and even that appears in the workspace as well. So let me tell you one more thing. So if you put a semicolon at the end of any line, that output won't be displayed in the command window, but that variable will be stored in the workspace. Okay, so let me repeat it once again. If you are using semicolon at the end of any command, that variable will be stored in the workspace, but that output won't be displayed in the command window. Okay, so here if I run it a is equal to 2, that variable a will appear in the workspace, but it won't be shown in the command window. And for b, I haven't put the semicolon, so b will be displayed like this. So let me try to run it. Now you can see that A and B are appearing in the workspace, but here A is not displayed, but B is displayed since there is no semicolon. So if I put a semicolon and run it, you can see that A and B are not displayed, but A and B are there in the workspace. So if you call A in the command window, you can see that it is coming. Similarly, if you call B, that is there. Suppose you are calling C, since C is not in the workspace, it will say unrecognized function or variable C. Okay, so that is about M file, command window, and workspace. So basically, you will be writing the programs in an M file, and if you run using the run button, it will be executed and the output will be shown in the command window, and whatever be the variables that are coming in the program, that will be stored in the workspace, and you can use that particular variables to perform the operations. For example, let me do let me do an operation. C is equal to a plus 5. Okay, c is equal to a plus 5. So what will be c? C is equal to a is 2, which is already in workspace. 2 plus 5 is 7, right? So if I run this, you can see that c is equal to 7 is displayed, and that particular variable is displayed in workspace. Okay, so I hope the structure of Matlab is clear. The different windows are clear. Now let me take a new script or M file to uh, to display or to generate unit step signal. So what we will do in this particular tutorial is we will try to show you how to generate different elementary signals that we have studied, like unit step, unit ramp, unit parabolic, unit impulse, which I will demonstrate now. Then you have the sinusoidal signal, then real exponential, and complex exponential is also there, but we won't be doing that right now. It will be coming as a part of some of the assignments. Okay, so so that is about the M file. Now let me start writing a program for impulse generation. So I have taken a new M file by clicking this plus. Now let me save this. So save, and I am naming it as uh, impulse underscore generation. Okay. Okay, good. So what are the first two lines? The first line is clear, second line is CLC. Now, if I write any code with the percentage sign at the beginning, that code will not be will not be executed. Okay. So if I use percentage sign at the beginning of any code, that particular line will not be executed. So that can be used to write some comments on the M file. Suppose if you are having a big M file and later you may find it difficult to understand what is there in the code. So you can use this commented lines to understand what is this code all about. So here I am using the comment to say that I am using this code to generate a unit impulse signal, and we have two different cases. So case one I am considering first, which is the discrete time case. Okay, so first I will write the code for generating unit impulse signal for discrete time case, which is also called as unit sample signal. So in order to generate a unit sample signal, what you need? So you know what is a unit sample signal. So unit sample signal or unit impulse signal is having the value 1 at n is equal to 0, and for all other instances, for all other n, the value of the signal is 0, right? So so you need to define two quantities. One, you need to define n, and second one, you need to define what is the value of the impulse signal at each n, right? So in order to define n, you need it's basically an infinite n, but for the sake of understanding, let's consider a limited sequence of values from minus 10 to plus 10. Okay, so I am defining n as minus 10, minus 9, minus 8, minus 7, and so on up to 10. Okay, 1 2 3 4 5 6 7 8 9 10. So what I can do is I need to define it as a vector. So either I can do it like this: minus 10, minus 9, minus 8, minus 7, and so on. But that is a tedious task. There is a easy way to get that particular thing as a vector. The easier method is that you can use colons. Okay, so minus 10 colon 1, what is the spacing, colon 10. Okay, so if you run this command, it's actually getting you minus 10, minus 9, minus 8, and so on up to 10 with a spacing of 1. So let me try to run this and show you what is the output. So you can see the output in the command window. Here n is minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, etc. up to 10. right? So this is our n. Now let me put the semicolon so that I am sure what is happening. Okay, so that is n. What is the second thing that we need? The second thing that we need is we need to define the amplitude. So let me use the variable name impulse underscore d to differentiate it from discrete and continuous. So impulse underscore d be the signal, and we need to define that also as a vector. Okay, so what is the dimension of n? So since you can see from the workspace, n is defined as 1 by 21 double, or it's a 1 by 21 matrix. There are 21 elements in the vector n. What are the 21 elements? It is minus 10 to 1, there are 10 elements, then there is 0, and 1 to 10 is another 10. So total 21. So for that, for impulse generation, what I want, the first 10 signals to be 0, then I want one signal to be 1, which is at n is equal to 0, and for the rest of the 10 signals uh, I want the value to be 0. Okay, so for that you can use a command zeros. It will be clear once I show the graph. So zeros 1 comma 10, so it will generate 10 zeros. Okay, that means for n equal to minus 10 the value is 0, n equal to minus 9 the value is 0, similarly till n equal to minus 1 the value is 0. There are 10 zeros. That's why I am writing zeros 1 comma 10. Then what you need? You need 1 ones 1 comma 1, or you can just write 1, that's also fine. Then the third one is zeros. Now how many zeros you require? There are 10 zeros. Okay, so first 10 zeros, then there is 1 1, and again 10 zeros, so that total it will become a vector of 21 elements. Okay, so let me try to run it and show you what is the output. So you can see the output in the command window. So you can see that it is having 10 number of zeros initially, and there is a 1 1 and remaining 10 zeros after that. Okay, so I have defined the x-axis, which is n. I have defined the amplitude, right? Now what you need to define, uh, so you have the x-axis and y-axis. What you need to do is you need to plot, you need to do to get a plot between this x and y. So in order to plot the discrete values or discrete signals, you need to use a command called as stem. Okay, so when you write stem, you can see the help. It is saying that stem helps in plotting discrete sequence data, while plot is the command which is used for continuous time cases. So in this case I need to use stem, uh, and suppose yeah, so stem, what is the x argument and what is the y argument? So you need to give stem n comma, n is the x argument, what is the y argument? Impulse underscore d. Okay, so remember that while using stem argument or plot argument, you need equal number of points. Here there are 21 points in impulse underscore d and 21 points in n, so you can plot between n and impulse d. If there are difference, you cannot have the stem plot. Okay, so now suppose I am running this, so let me put the semicolon here as well. Okay, now I am running this, it will generate a figure as well. Okay, so a figure, so this is the figure of stem n comma impulse underscore d. So in x-axis n is coming, so from minus 10 to plus 10 with a difference of 1 each, and the amplitude for initial 10 values it is 0, then for one value it is 1, then again for 10 remaining 10 values it is 0. Okay, so this is the plot of an impulse signal or a sample signal. Okay, now you can add color to this graph. One of the things that you can do is you can give a title to the graph, and you can give the title as a text. So to write the text you need to use the single inverted commas. So let me write the text as sample signal u of n. So whatever you write in single inverted commas, it will appear as a title for the graph. Okay, so let me try to run this. Okay, so now you can see that that particular title appeared in the figure. Now next thing what I would like to do is I would like to add the x-axis and y-axis. So the commands to write the x-axis is x label. So in x label, let me write as uh, n, that's enough. And y label, let the y label be amplitude. So in single inverted commas, you need to write amplitude. Okay, and if you run it, you can see that uh, n is appeared here and amplitude appeared here. Now one more thing I would like to do is I would like to arrange the axis. I want the y-axis goes from -0.2 to 1.2. So for that you need to give the command axis. uh, First you need to define the length of x-axis. So for x-axis I just need the same axis -10 to 10, and y-axis I need -0.2 to 1.2. Okay. Okay, so now the figure is much better, right? So now it looks like a discrete time signal or a discrete time sample signal. Fine. So this is how you will generate a discrete time sample signal. And now let me write the code for generating continuous time impulse signal. And you know that so it is case 2. Let me close this window. So case 2 continuous time case. So you know that the continuous time impulse signal is basically an ideal case, because you want at 0 it is infinity, and at other points it is 0. At t is equal to 0 it need to be infinity. So it's an ideal case, it's not a practical case. But to understand it, what you can do is you can define uh, a variable t, which varies from -10 to 10, but uh, with a difference of 10. Oh, sorry, 0.1. Okay, so what is t basically? So t is basically -10, -9.9, -9.8, -9.7, and so on, and it continues till 0. Then it continues to 0.1, 0.2, etc. up to 10. Okay, so there are 201 points. So let me run this. So if I run this, that figure will come. Okay, fine. So let me close this figure. You can see in the workspace that T is now a 1 by 201 matrix. Okay. So let me define impulse underscore C, which is the continuous case, as uh, can you identify how many zeros and how many ones? So zeros 1 comma 100, ones 1 comma 1, again zeros 1 comma 100. Okay, so this will be an impulse in continuous. I have said previously it is not an ideal unit impulse in continuous is not practical, but to understand, that's all. And the command used to plot in continuous time case is, I have mentioned previously, it is plot uh, t comma impulse underscore c, right? So let me try to run this. So if I run this, you can see that there is a continuous time unit impulse signal, and it's not perfectly impulse. As I said previously, it's not practically possible. Now you can see that I have run this program, but the discrete time figure is not shown, because first I run the discrete time figure, and above that the continuous time figure is being plotted. So in order to see it separately, what you can do is you can name the figures. Okay, so first figure, let me name it as figure 1. Okay, so this is the first figure, and the second figure, which is the continuous time case, I need to define it as figure 2. Okay, so let me try to plot it now. Now I am running the M file. You can see that, yeah, so it appeared in two figures. So this is figure 1, which is a discrete case, and figure 2, which is the continuous case. So there is fine. There is a warning: an error occurred while drawing the scene. Okay, so no problem. So don't worry about that particular problem for the moment. So this is the way how you will generate a signal in discrete case as well as the continuous case. Okay, so I hope it is clear. Now what I'll do is I'll just give a screenshot of the different commands that you can use in MATLAB, and after that my student friends will help you in understanding how to plot the remaining elementary signals that we have studied in the class. So these are the basic commands that you can use in MATLAB. Uh, so there are mathematical functions that you can use. There are special operators, array operators, a control flow. These are important things. For loop you can use if you have studied these in C programming. So similar usage you have. For plotting you have plot and stem. There are other plotting commands as well, and so you can go through this, uh, and the there are some symbolic math functions as well, so you don't need to worry about these for the moment, but these commands will be handy later. So you can differentiate, integrate, limit, Taylor series, summation, simplify, expand, and so on, solving equations. So these are very much useful for our later analysis. So Fourier, inverse Fourier transform, Laplace transform, Z transform, and so on. So here there are two important functions that we have already studied. One is Dirac delta function, unit steps function, and so on. So these are for symbolic math functions that we'll learn later. So you can go through this. So I'll stop by saying one more thing. The critical, this is a critical thing, that if you have a doubt of any of the command that you know, what you can do is you can go to command window and type help with the space and write the command. Suppose you know that there is a command for zeros and you don't know what is the argument, what is the how to give that command. What you can do is you can give help zeros, and if you give that, it will give what is that command all about. Okay, so zeros is a zeros array. 0 n is a n by n matrix of zeros. So zeros m comma n is a m by n matrix of zeros, and so on. So you can use this particular command help with the command or the keyword to understand about that particular uh, command. Okay, so CLC. So, so I am stopping here. I am passing the baton to the next elementary signal, and the next student will help you in generating unit step signal. So, thank you very much.